Hey, welcome back everybody. So last time we worked on the unit circle and we were working forwards to find the exact value of trig ratios. So today's lesson is about working backwards to find an angle. Part of the lesson is working on the unit circle to find the angle, and the other part is using your calculator. So first of all, the unit circle can also be used to work backwards from the value of the trig ratio to determine the rotation angles within a specified domain. That domain is not always going to be from 0 to 2 pi. It's going to switch up and change around. If the value of the trig ratio is not familiar to you and not from the special angles that we covered with the unit circle, then a calculator can be used to determine the rotation angle. And that will be covered in our next lesson, which is lesson 4 in your workbook. And we're kind of switching things up. We're actually doing lesson 4 after lesson 5 that you've already discovered with the last one. Okay, so first of all, determine the angles for each of the following trig ratios and domains. So you always have to check your domain before you write down your answers. Okay, so we have sine theta equals root 3 over 2. Now you should look at that and go, oh, I recognize that from the unit circle. Okay, so we draw a little unit circle, and here's your process that you're going to do. You're going to go sine. Now remember, sine on the unit circle, sine is your y coordinate. Okay, we notice that it's positive. Okay, so check off which quadrants y would be positive, and that would be here and here. Think about if you're plotting a coordinate above the x-axis, y would be positive. And here, root 3 over 2, that is our big coordinate of our big little that we talked about last day. So we're looking where y is positive and big. Okay, so it's positive here and here. So let's look. It's either going to be big here or here. So think about that. Which one would have a bigger y? This one would have that kind of y value, and that one would have this kind of y value. So obviously the first one there, this one, would have the bigger y value. Okay, so you draw that in. And then you go, okay, now in the other quadrant, the big y value should be happening also here, because that would also have a larger y value. Okay, so there's our two terminal arms, and now we just have to name those angles. And when you go to do that, you want to look at your domain to determine how you're going to write that down. Oh, and what the angle is called is whatever's inside of our trig function, theta. So we have theta, okay, right here, and we'll talk about the other ways we could name that later. Okay, so theta equals, okay, so if you look at this, we have three basically that we looked at with the unit circle for the denominators. We had ones that were over 6 that were close to the y-axis. We had ones that were over 4, pi over 4, that were halfway between, where the sides are equal, and then we had this one where it was closer to the y-axis, and those were big chunks of pi. They were pi over 3. So this would be 1/3 of a pi, this first one, and the second one would be 2/3 of a pi. And that fits our domain from 0 to 2 pi. Okay, so next question. Cos theta equals negative root 2 over 2. Okay, so when you hear cos, you should think x coordinate on the unit circle, and it appears to be negative, and then we're looking at root 2 over 2. Okay, and when you look at root 2 over 2, you remember, oh, that's where they're the same. That happens at the quarter pies. Okay, so we draw this. First of all, where x is negative would be over here in these two quadrants. Where the side lengths would be the same would happen exactly halfway between. And there we go. Okay, now this is a weird way, I know, to write the domain, but it's called interval notation. And this way of writing your domain is exactly the same as this. The square brackets mean that 0 is included. It's like the equal to sign, basically. And then how you say this is theta can be from 0 to 2 pi. And those are kind of your endpoints, your left endpoint, your right endpoint. And again, a square bracket means 2 pi is included in our domain. Okay, so to write our answer now, theta, because that's what's inside of our cos function, theta equals, all right, now these were the quarter pies, and if you think about it, this one would be how much of the way to pi? Well, there would be 1/4, 2/4, 3/4, so 3/4 of a pi Okay, and then we are 1/4 more than pi, which would be 4/4. Okay, so that would mean we'd be at 5/4 of a pi. Okay, number 3. All right, something new coming at us here. We have a squared on our sine function. Well, first of all, we need to get rid of that. So we would square root both sides of our equation to get sine theta equals, now when you square root both sides, there's the positive and negative possibility. So plus or minus square root of 1 is 1. All right, so we are looking for sine, which is y. It's positive or negative. Okay, so that would mean we're in all 4 quadrants possibly, right? Where it's positive or negative. But look at this coordinate, y equals 1. Remember the radius on the unit circle is equal to 1? So if we have to be where y is 1, that would have to put us right at the end so that our radius was equal to 1. Coordinates up here, 0, 1, the y value is 1. Okay, so that's one of our answers. Okay, the other one is down here because we're also allowed to have -1 as our coordinate, 0 and -1. And there we go. There's where our 2 terminal arms would satisfy that equation, these 2 terminal arms. Okay, so now we write our answer. Theta equals, name that first terminal arm. We would call that pi/2. And normally we would call this terminal arm, if our domain was 0 to 2 pi, it would be 1, 2, or 3/2 of a pi. But check our domain. We are going from -pi, which means from here to here. Okay, so that this pi/2 is still okay. Sorry, negative pi, that was positive pi I just showed you. Okay, so negative pi would be this direction. So that means this terminal arm would be called this angle. So it would be a negative angle, and it would be half a pi. So negative half a pi covers this terminal arm, and positive half a pi covers the other one. And we have no further answers within our domain. So there we go. There are our answers. Alrighty, so let's take a look at the next question. All right, tan is always an interesting one. They're usually a little more tricky. So tan theta, as you remember, tan is y/x. So let's put that over here just so we can compare. Okay, so to end up, oh, and it's positive too. So let's first of all check our quadrants. So where tan would be positive, the ratio of our y over the x would be positive. So y and x are both positive in quadrant 1, so that's definitely one of our quadrants. But we would have to have the signs the same on y and x, so that would mean we'd also have to be in quadrant 3 where they're both negative. Negative divided by negative, positive. Okay, so we have our quadrants. Now we've got to figure out where we are. How on earth would we get, and you're probably thinking, oh, I'm at the 0, 1s or 1, 0, you know, at your pi/2s. We're not actually. To get y over x to equal 1, that means y and x had to be the same. Maybe it was 5/5, 3/3. Or where are our coordinates the same? It would be at √2/2 over √2/2, essentially. That's how we got 1 was dividing by the same coordinates. So where does that happen in quadrant 1? Yep, you got it, right at the pi/4. Okay, and in quadrant 3, it would be also at 1/4 pi, and we got to name that in a minute. Notice tan is in a straight line. That always happens with tan and cotan. The other answer is in the straight line. Okay, so let's name those angles. All right, checking our domain, we're going from -pi to pi inclusive, including both of those endpoints. So negative pi would be this direction. So I would call that terminal arm negative, let's see here. These are quarters, and that looks like 3/4. So -3/4 of a pi. And then this terminal arm I would call positive pi/4, just 1/4 of a pi this time. And there we go. There's our answers. Okay, let's take a look at the next one. So we have cotan. Oh, isn't that lovely? So cotan, I'm just going to rewrite this, I think. We have √3, and we know cotan is a reciprocal of tan, which was y over x. So cotan would be x over y. Now this isn't a fraction right now, but normally when we say root 3, it's root 3 over 2. So I'm just going to change that to the root 3 over 1. Okay, and then because I know it's usually root 3 over 2, I'm going to make that over 2. And you're going, no, wait a minute, you can't just divide that by 2. You're right, I can't. So I'm going to divide the bottom by 2, and then it's still equal to 1. I haven't changed anything. I've divided both the top and bottom by 2. Now when you look at it, you go, oh, I recognize those. Root 3 over 2 and 1/2. Those are those triangles where they're big little. So we're looking where cotan is positive. So again, the coordinates would have to be the same. And that would be quadrant 1 and quadrant 3. And we want to know, if you compare this, where x is big. So where x would be big would be here rather than up here. That would be little x, because we're talking about x here. Okay, straight line to find the other one. So we go like that. And now we just have to name those angles. This time we're not writing theta equals. Look what's inside. That is called beta, another Greek alphabet letter. So beta would equal. All right, so naming this angle, those are those little tiny chunks of pi. That's what happened when pi was divided into 6 pieces. So the first one here would be pi over 6. And the second one all the way around. So to here would have been 6 over 6. And we are one pass, so that would be 7 over 6. Check your domain. Probably should have checked it before we did that. Oh, look at this. Beta can only be between 0 and pi. We went a little too far then by writing down that second answer. So our only answer would be pi over 6, because 7 pi over 6 is beyond our domain. We wouldn't include it. Okay, let's try secant here, and this symbol is called alpha. Again, another Greek alphabet letter, and it looks, I like to think of these as like a fish. Okay, so secant alpha equals 2. Okay, we've got a few things going on. First of all, secant. We didn't really talk about the coordinates of secant, so we need to change that to its reciprocal. Okay, so the reciprocal of secant is cos. I'm going to basically reciprocal the left side right away. So I would have cos theta, which means if I, reciprocaled or flipped the left side, I need to flip the right side as well. So that would become 1 over 2. Okay, everybody with me on that one, I hope. Then we're off to what we had before, which is figuring out where cos, which is x, is positive and little. That 1/2 is our little coordinate. Okay, so you draw your unit circle. Where is cos, which is x, positive? X is positive over here in quadrant 1 and quadrant 4. And we want to know where it's little. So we've got a choice of either this one or this one for our terminal arms for big little. We want where cos, which is x, is little. Well, x would be smaller here, which means this is our answer. Quadrant 4 down here. Now you may have started to notice that tan, you go in a straight line to find the other answer. Cos, you reflect over the x-axis, cos x, to get the other one. And sine, you reflect over the y-axis to get the other one. Okay, so let's name those two angles. All right, so check your domain. This domain, notice we have a square bracket and a round bracket. That means negative pi is included in our domain. See that equal to sign? Okay, oh, that's not an infinity. And 0 is not included in our domain. So this and this are exactly the same thing. So we're going from negative pi. This should be fun. Okay, negative pi is there. So we could name this terminal arm as negative, let's see, that's a big chunk of pi. So those were the thirds. So negative pi over 3. And then the other angle, is to 0. Oh, so I can't include this angle in quadrant 1. So that would be my only answer, negative pi over 3. All right. Okay, so questions 7, 8, and 9, we're running out of time, so I think what we'll do is we'll finish that up in part 2 of the video, as well as looking at ones that aren't on the unit circle and using our calculator to do those ones, and that would be in your workbook. Okay, so we'll see you in part 2.